So let's look at the periodic table. This is a information-packed table from the National Institutes of Standards and Technology, or NIST. It has a lot more information than you need, but it's very useful. On the actual exam, you'll be given a periodic table that has names and does not have things such as, well, we'll get into this. If we look right here, you can see that you actually have, so we have the atomic number here, we have the name, the weighted average atomic mass, ionization energy, we'll be talking about that. This is the ground state electron configuration. That's going to be super helpful when we get to that in a couple weeks. And so this right here is a physical chemistry bit of information that makes no sense right now and won't make sense until you take physical chemistry. So you won't need any of that, but it's there if you need it. So maybe just put this away. So what I want to show you is there are also in here, this table has a bunch of constants, such as the speed of light, Planck's constant, this charge of electron, which you already talked about, mass of an electron, which you already talked about, and some other things as well. Mass. We can see the mass of a proton, and mass of a electron. We can see that those are the values we have, and some other constants as well. So anyway, what I really want to show you is a couple things. You can see that we have here different phases. So solid, liquid, and gas. So you'll notice that the only liquids that we have for these are mercury and bromine. That is a great chemistry trivia question. Which of these are naturally found as liquids? Only two, mercury and bromine. We see the gases are noble gases and some of our naturally occurring diatomic gases. So we have nitrogen, oxygen, fluorine, bromine, and iodine. And actually there's one more that's naturally occurring, and that's hydrogen. These are the 7. So we have 1, 2, 3, 4, 5, 6. So it kind of makes a 7 with a hydrogen up top. Those are the 7 naturally occurring diatomic molecules. You do want to know that. That's the most stable form you'll find those molecules in, just FYI. That'll be helpful later. So we can generally break down the periodic table into metals and non-metals separated by the metalloids. So the metalloids are going to be bromine, silicon, arsenic, tellurium, and then we have germanium and antimony are going to be the kind of, they make this ladder. I might have done the ladder a little wrong, but whatever. Those are the elements that have both metal and non-metal properties. So anything on this side, so over here, these are all non-metals. And over here, we have, this is group 1 and group 2. So we call this whole row group 1 metals, group 2 metals, and they all have very similar properties. They have periodicity. This is how the periodic table was developed by Mendeleev. There was a periodic nature of reactivity to specific things, such as group 1 metals react violently with water. So if you take hydrogen, lithium, sodium, potassium, rubidium, and cesium, they all react by making a hydrogen gas when you add them to water, and there's an explosion because a hydrogen gas explodes when this exothermic reaction happens, or this produces a lot of heat. But as you go down the periodic table, there is a progressive increase in the reactivity, the speed, and the amount of hydrogen gas, and then generally the explosion. So the reactivity is the same, but there's slightly differences there. So we call these group 1 and group 2 metals. We refer to that a lot. So groups go down, and so you can see here we have the group go down, and the periods or families go across. And so we tend to use the word group a little bit more than we use period or family, just because there tends to be more a commonality amongst groups than down a row. So we have transition metals that go here. Transition metals. We focus on the first couple rows. So these are the transition metals. They transition between the group 1 and group 2 metals and the non-metals. And down here we have our actinide and lanthanide series. And the important thing about this, if we look at the periodic table, it kind of looks like they come out of the periodic table like this, and they actually do. And so I actually have a long table. So this is what happens if you were to actually put these into the periodic table. You would have these make the periodic table really long. So what they do is they say, well, we're actually going to take these out, put them down below, and move everything over, and you get this table. It's a little more condensed. There's no other reason why it is like that. So it can be a little confusing. But these both, the lanthanide and actinide series are pretty unstable. So there's a periodic table that is in front of Salem Hall. So the fun joke to say is if people are ever hanging out around the periodic table, you would just say, hey, don't sit on that bench, because the bench is made up of the lanthanide actinide, because I hear it's pretty unstable. And then you walk away chuckling, and they just kind of stare. I promise it's pretty funny for you. Anyway, so we're going to need to remember metals and nonmetals for naming. So nonmetals and nonmetals have different names than metals and nonmetals. So you need to know, and we do a lot of naming with our nonmetals in the first or the second row. I mean, we don't really see a lot of the noble gases tend to be very stable and not need bonding to increase their stability. Generally, bonding is a way to increase stability. Noble gases have ground state electron configurations that are very stable and tend not to bond, though we do see elements such as xenon bonding. And the last thing is everything here in green and a couple other spots are made artificially prepared. I mean, they are not naturally found or naturally occurring, not found in nature. You have to make them, and generally their lifetime is very short, and that's why they have these weighted average atomic masses that actually are in parentheses, and that they're not in a high enough abundance to ever form isotopes. So they generally just have their nuclear decay goes away. You lose protons. It no longer is the element anymore, and so therefore no isotopes exist, and so that's just theoretical in nature, though they can be created for small moments of time. So that's periodic table overview. And we will be using this. I will post this as well, so you can use this periodic table. It has lots of useful information. Good to put in your binder with all your stuff.